Dear participants, welcome to the second session of Day 2 Room 1 presentations. In this session, we are hosting Professor Dr. HALUK AKGUN from the Middle East Technical University and also representing the Chamber of Geological Engineers of Turkey, Dr. KARIMA ELMASRI from the University of Tripoli, Libya, Professor Dr. NURAY from the Erciyes University, Turkey, and Professor T.PHANI MADHAVI from the Bapatla Engineering College, India. Welcome, professors, and thank you for joining this session. Now I would like to invite Professor Dr. HALUK AKGUN to deliver the presentation.
Thank you very much, Chairman. My name is HALUK AKGUN. I'm from the Middle East Technical University Department of Geological Engineering, and I am representing the Chamber of Geological Engineers of Turkey as well. And in my keynote, I will talk about underground waste repository isolation from a geotechnical point of view. I will give an introduction to the topic, and I will concentrate on two different aspects of nuclear waste repository sealing. The first part will concentrate on bentonite sand mixtures, and the second part on cement seals that I have performed studies on. And then I will present my summary and conclusions at the end. This is an artist's concept of what a nuclear waste repository will look like in the future. At the surface, we have the surface waste handling facilities, and we have boreholes, shafts, and adits to dispose this nuclear waste underground within the repository. In the repository, meaning geological repository. And all these borings, openings in the vicinity of a nuclear waste repository need to be sealed efficiently in order to prevent the migration of the radionuclides to the surface environment. So we are usually installing plugs or seals here in these shafts, access ways, tunnels, boreholes, any opening within the vicinity of an underground waste repository. The materials that are popular is bentonite sand mixture, and expensive cement formulations for this purpose. And what happens is that when we put these sealings or sealants or seals or plugs, we call them, we will have axial stresses on them because of the water column on them, or because of the thermal effects, increase in temperature or heat effects due to the emplacement of this waste, nuclear waste, and also due to the curing of the sealing material. And I have two objectives today. In the first objective that I will pursue, I will talk about bentonite sand mixtures, selection of an optimum mixture, and also some geotechnical properties, determination of some geotechnical properties, and also some borehole stability analysis, because after the mixture is being selected, then we have to do some stability analysis in terms of determining the shear stresses at the interface, because these axial loads produce shear stresses at the interface between the sealant and between the host rock. And in the second objective, so in the first one on the bentonite sand seals, then we will go through a factor of safety approach and try to determine safe lengths of these sealants due to different varying water columns. In the second aspect, in the second part, I will talk about the tensile strength generation, because we have tensile stresses generated at the interface between the plug and the rock. And these tensile stresses, if they are excessive, they might lead to tensile fracturing, and this whole process can lead to the violation of the containment objective of this system. So the first part is bentonite sand seals, and what we have done is we have used different percentages of bentonite mixture in our bentonite sand mixtures. And we have used 12.5, 15, 17.5, and 20% of bentonite. And we compacted this material with sand, and we tried to select an optimum mixture satisfying the regulatory requirements. And as an additional objective, we also studied the stability of these boreholes plugged with bentonite sand, and we looked into the shear stress, looked into the shear strength, and tried to design bentonite sand seals with acceptable length to radius ratios. Then, of course, to do the stability analysis, we had to perform also some geotechnical tests on the optimum bentonite sand seal selected, and this included some swelling tests, some mechanical and shear strength tests, where we shot to find the swelling pressure, the Young's modulus, cohesion, and angle of internal friction. And the ultimate objective here for the bentonite sand seals was to find or determine an acceptable length to radius ratio so that we had a safe seal. We studied the geotechnical properties of this bentonite. It contained at least 90% montmorillonite, and these are the geotechnical properties that we have determined. Specific gravity 2.74, liquid limit 450%, plastic limit 35%, plasticity index 415%, and positive cation exchange capacity in milli equivalents per 100 grams was about 100. The lean sand component had a hydraulic conductivity of 10 to the minus 4 meters per second, specific gravity of 2.64, void ratio of 0.45, and a maximum compacted dry density, maximum compacted dry unit weight of 18 kilonewtons per cubic meter. So we used the standard Proctor compaction apparatus, and we used 4 mixtures starting from 12.5% to 20% of bentonite in these bentonite sand mixtures, and we compacted them at various molding water contents. And this is an example of one of the tests on a 15% bentonite content for a bentonite sand mixture, and dry unit weight versus molding water content. And we, as you know, we almost always get a bell-shaped curve like this for the compaction curve. And we shot to determine the permeability or hydraulic conductivity of these mixtures at close to the optimum point, where this is the maximum dry density, this is the optimum moisture content, as you know, and this, we try to do our permeability testing later on when we place these samples in the compaction permeameter. We usually did that on samples compacted 2% on the wet side of the optimum. And so this is the 80% saturation line, this is the 100% saturation line, as the curve implies. And this is the result of our compaction that we obtained. For 12.5% bentonite content, the optimum moisture content was 15.8, and for that of a 20% bentonite content, it went up to 16.3 almost, and the maximum dry unit weight for the 12.5% bentonite content was 16.20, and 20% bentonite content was 15.10. So with increased bentonite content, we had an increase in water content, or increase of the optimum moisture content, and a decrease of the maximum dry unit weight. And then we placed these samples in the compaction permeameters, and what we had, this is a schematic setup of that compaction permeameter that we used. And we could test 4 samples at the same time. We had a vacuum pump, de-airing tank, and on these samples, we had 4 samples. One of these samples is given as an example in the sketch. The length of the sample and the cross-sectional area of the sample are denoted by capital A. Length is L. And H1 is the total head at time T1 versus this is going down in the falling head test. H2 at time, the total head of H2 at time T2. And then we calculated the hydraulic conductivity of these mixtures with the traditional equation for falling head test, where A is the breadth cross-sectional area, L is the length of the sample, A is the cross-sectional area, H1 is the total head at time T1, H2 is the total head at time T2. According to the hydraulic conductivity results coming out of the compaction permeameter, we had hydraulic conductivity is obviously decreasing with bentonite content, and if we were to use the federal regulations for landfill liners, which is 10 to the minus 9 meters per second, we've discovered, or we found out that the 20% bentonite content in our bentonite sand compacted mixture satisfied the regulatory requirement of 10 to the minus 9 meters per second. So the optimum bentonite content for the sample that we selected was 20% bentonite content. And after we selected this as the optimum content, optimum mixture, let's say, we did some geotechnical testing to determine the swelling pressure, the Young's modulus, and the cohesion and angle of internal friction, so that we could run a stability analysis on these mixtures, because the stability analysis required the shear stress, required the shear strength, and the shear strength and shear stress required these values. Then we did an analysis of the seal rock interface strength of bentonite sand seals. What we did is we selected the 20% mixture, and this is the geometry and coordinate system utilized for stress calculations for an axially loaded seal in rock. Think about this as a cylindrical sample, a core, and we have a coaxial hole in it to simulate a nuclear waste repository where we have openings. We need to seal those openings for the purpose of containment. So in this kind of a geometry, we have the compacted bentonite sand seal as the sealant, as the borehole plug, and we have rock. And we have an axial stress applied to this compacted bentonite sand seal. And like I said before, this might be due to a water column on top of the seal. This might be due to thermal effects, because we're going to have an increase in temperature after the waste is emplaced and after the seal is emplaced. The seal, if it's a cementitious kind of seal, it produces temperatures up to 66, 70 degrees Celsius. So that's also another effect in nuclear waste disposal in terms of plugging the borings. Anyway, so if we look at the geometry, this is sigma z. We have an axial stress applied to this seal. We have the compacted bentonite sand seal. It's a swelling material, that's why it's going to exert some swelling stress. And well, the coordinate system at the loaded end of the compacted bentonite sand seal, we have z is equal to 0, so the coordinate starts from the loaded end of this interface, and z points down, the coordinate z points down this way, and z is equal to L, which is the length of the specimen at the bottom of the compacted bentonite sand seal. The interior radius is A, the outside radius is R, and sigma z is the axial stress applied to the seal. And all this axial stress is transferred to the interface in the form of shear stresses, if we talk about the equilibrium condition. And this results in an exponential shear stress distribution, because this is a second order differential equation, and with putting the boundary conditions results in an exponential kind of shear stress distribution. Sigma s is the swelling pressure generated by the seal. Z is the axial distance from initial location of the loaded end of the seal. A is seal radius, R is the rock cylinder outside radius, and L is the seal length. So our purpose here was to through using equilibrium equations and through knowing that this bentonite sand seal is going to compact and is going to deform, and this deformation and this axial stress is going to be reflected to the interface as shear stress. And the purpose here was to find the maximum or the peak shear stress. And we were able to do that because the peak shear stress induced by axial loading, the peak shear stress for an infinite for a plug, an infinite rock mass, or an in-situ seal, if we want to name it, is given by this equation. And as you can see, this is an exponential kind of distribution. We have the applied axial stress at failure, and gamma is a parameter that I will be giving on the next page. And the good thing about this is it contains length to radius ratio, so we can iterate this equation to find the required length of a seal like this that satisfies a factor of safety without any shear failure. So gamma is equal to this term, where Vs and Vr are the Poisson's ratio of the seal and of the rock, and Rc is the limiting critical radius, and beyond this radius, shear stress is not transferred into the rock, and we have negligible axial stresses within the rock. And what else here? Alpha is given by this, alpha is this parameter here. Es over Er is the modulus ratio, and modulus ratio meaning the ratio of the Young's modulus of the seal or of the plug to the Young's modulus of the rock. And L is the seal length. RC, I think I have covered it all. Then we found the shear stress. Then we need to find the shear strength, the peak shear strength, which is given by this equation. In simple terms, we can use a Mohr-Coulomb criterion here. And sigma NP infinity represents the normal stress at the interface. So it is against the cement swelling stress, the normal stress at the interface. And we want to get the peak normal stress at the interface. And C is the cohesion, phi is the angle of internal friction, and sigma NP infinity is the peak normal stress across the seal rock interface for an in-situ seal in rock. And what are the components of this normal stress on the interface? Of course, due to a Poisson effect, any axial stress exerted is going to lead to a radial stress at the interface, which is given by this sigma rp infinity, which is equal to sigma z times L, alpha. And alpha, I have given this equation for alpha here. And sigma s is the cement swelling pressure. So the factor of safety can be calculated because we have our resisting forces and our total driving forces. Shear strength over shear stress is our factor of safety. So our purpose here was to determine the factor of safety as a function of length to radius ratio for different water column heights. We used water column heights of 100 meters, 200 meters, and 300 meters for our stability analysis. And we came up with this chart given in figure 5. And so this is simply the factor of safety as a function of bentonite sand length to radius ratio. So, and for varying water columns of 100 meters, 200 meters, and 300 meters. So if we were to have a water column height of only 100 meters, for a factor of safety of 1 for the limiting equilibrium case, we could get away with maybe a length to radius ratio of 3, as you can see from this chart. But if you use if there's a water column physically there for up to 200 meter thick, then we can use a length to radius ratio for this mixture of 5, which satisfies the factor of safety. And if we were to use, if there was a water column of 300 meters, we needed a length to radius ratio of 10. And it is so, inspection of figure 5 leads to a recommendation to utilize a seal length to radius ratio, L over A, of at least 10 to attain a factor of safety of about 1, which is this point right here, generated by the worst case water column scenario of 300 meters acting axially on the seal. The other problem I want to tackle today with you is the tensile strength of cement seals that we had from earlier studies that I have performed. So as a sum, if we have a seal here, due to the axial stresses on this seal, we might have tensile stresses generated at the interface between the seal and the host rock. And if we have any tensile fracturing, that's the last thing we want. And then we will have violation of the containment, which is a really bad situation that we don't want to face. We wanted to test this scenario of a borehole or shaft within the rock, and that we use for access waste to deposit the waste, the nuclear waste. So what we did is we had a core of rock. There was a cylindrical core. We put a coaxial hole in it. We plugged it with cement, self-stress 2 cement that was provided by Dowell Schlumberger at that time. And we wanted to simulate the condition of this water column, axial load. What is the effect of that on the cement plug that we have? We have temperatures up to, at that time, calculate up to 90 degrees in the sealant areas. So we wanted to use temperature as one of the parameters. And the host rock was not fully saturated, it was partially saturated. We wanted to study the effect of degree of saturation on this kind of a sealing system. So we cured the samples in an environmental chamber so that we could have degree of saturations ranging from 20% to 80-85%. And also we could store the samples in these environmental chambers varying from room temperature, ambient temperature, all the way up to 90 degrees. And during testing, what happens is we put this equipment in an MTS tester, and we applied an axial stress to this cement plug. Then we wanted to measure the failure load, which is the push-out test, axial strength, in other words. And we also wanted to measure the displacements of the top part of the plug, where we used a dial gauge and an LVDT. And also we wanted to measure the bottom displacement of this plug also, see what's going on. And we put an L-shaped rod at the bottom of this plug, and we had an LVDT and a dial gauge resting on it so that we could measure the bottom displacement of this plug as well. And in this kind of arrangement, we also put a steel cylinder and also a heating tape around it. So we had the heater controller also. So we could also apply high temperatures to this sample that was cured in an environmental chamber. What I'm trying to get to is some of the samples showed tensile fracturing. And when this tensile fracturing happens, then it is not a good scenario for a nuclear waste disposal site, and any kind of tensile fracturing should be eliminated or minimized as much as possible. So what we did was we calculated the tensile stress distribution within this kind of a hollow cylinder, and the tensile stress distribution is given by this equation. And if I put for R the interior radius of this sample, this is going to be giving me the maximum tensile stress that is possible. And sigma n is the radial stress at the plug rock contact, and the total radial stress, normal stress, is given by this equation here, where we have the radial stress resulting from axially loading the plug, and we have radial stress resulting from the thermal normal stress, and we have also the radial stress resulting from the differences between the expansions, coefficient of expansions of the plug and of the rock, and also we have the cement swelling pressure. So these four components, they are given by these equations here. Lambda is given by this equation, so this is for the radial stress due to an axial stress applied to this plug. Lambda is given by this equation, beta is given by this equation. RC again is the limiting radius, where all the shear stresses and axial displacements in rock can be considered negligible. And sigma RT is the thermal radial stress due to the thermal axial stress within the plug or plug rock interface. And sigma RI is the difference, the radial stress, the constant radial stress, because of the difference of the thermal radial expansions of the plug and of the rock. So this is the peak normal stress happens at the loaded end of the plug. It happens, and this is the equation for that. We plug this equation in our tensile stress calculations, and here we want to make sure that this maximum tensile stress developed should not exceed the tensile strength of rock in order to prevent any tensile fracturing. So these two case studies I wanted to go into in this keynote. Summary and conclusions. The main objective of this study is to investigate an optimum compacted bentonite sand mixture for the isolation of underground waste repositories through performing compaction and flow tests. An additional objective is to investigate the tensile strength of cement seals. The results of the compaction permeameter tests led to a recommendation to select an optimum compacted bentonite sand mixture having a bentonite content of about 20% to satisfy the minimum regulatory hydraulic conductivity requirement. Analysis of seal rock mechanical interaction in regards to reduce the possibility of seal slip led to a recommendation to utilize a bentonite sand seal length to radius ratio L/A of at least 10 to attain a factor of safety of about 1.03. The tensile strength of rock should not exceed the maximum tensile stress in rock to prevent any tensile fracturing and violation of the containment objective, obviously. These are the references that I have utilized, and thank you for listening to me.
Thank you very much for your valuable presentation, Professor AKGUN. I think we don't have any questions at this moment. So if there are any questions, I will direct them to you, Professor, at the end of this session. Okay. Our second guest is Dr. KARIMA ELMASRI from the University of Tripoli, Libya. But I guess Dr. KARIMA is not with us now. Therefore, I would like to share a pre-recorded video from Professor Norzila Binti Othman from the University Tun Hussein on Malaysia.
Bismillahirrahmanirrahim. I'm Norzila bint Osman from University Tun Hussein on Malaysia. Today, I would like to share a research on coagulations and flocculation process using lemongrass extract for pollutant removal in the raw water. The content of my presentation consists of introductions, literature review, methodology, result and discussion, and finally on conclusions. Why we did study on this research? Firstly, Malaysia depending very much on surface water for water treatment. But unluckily, surface water was highly polluted by suspended solid, organic content and also microorganisms. Due to high provisions of clean water supply, the source water should be well treated. One of the possible solutions to treat the water is through coagulations and flocculation process. In this research, basically we are focusing in using starch-based coagulant for treating the water. As the problem statement, why does we start with the research? Currently, if we use high chemical in the treatment, so detrimental effect of the chemical coagulant and most possible effect of the chemical coagulant is due to sickness like Alzheimer's. If we use less dosage of chemical coagulant and disinfection at the final product of the water, it would be created by product in the water treated. Partially substitutions of chemical coagulant may also cause pathogen breakout in the drinking water. Therefore, significant health concern related to contaminant used to apply on monomer for starch modifications. The objective of this study are to characterize the chemical compositions and antimicrobial properties of lemongrass extract for cassava field starch modifications. Secondly, to characterize the surface morphology, elemental distribution, functional group, and also chemical compositions of alum, CPS, and also modified CPS. Thirdly, to optimize the effect of pH, coagulant dosage, settling time for alum, native and modified cassava field starch as sole coagulant, and combinations of alum CPS and alum MCPS for turbidity, total suspended solid, COD, and E. coli removal in raw water that spike with the E. coli. The fourth objective is to specify the mechanism that govern the coagulations and flocculations. The scope of the study that being designed for the study following the objective of the study. Some of the limitations in this research are cassava field starch-based coagulant as sole coagulant or used in the combinations of alum are only proposed as a green alternative to reduce the dosage of chemical coagulant and disinfections. Coagulant developed were only compared with aluminium sulfate that was one of the common coagulant that been used in water treatment in Malaysia. Current research only covered the few numbers of parameters such as turbidity, total suspended solid, COD, and also E. coli. Economic analysis of coagulant was not carried out in the study. Why this study is significant? This study is significant due to develop dual functions coagulant containing coagulation and disinfection process to overcome the shortcoming of the conventional coagulant. Conversions of plant waste into a value-added coagulant that was cassava peel has been converted into starch-based coagulant. In-depth study in optimizing significant factors affecting the coagulant performance, synergistic mechanism study would further provide the theoretical basis for research and development. What are the literature review behind the study? From the past, we can understand a lot of natural coagulant had been used to treat the water or the wastewater such as chitosan, plant seed, tannins, agriculture waste, cactus, and also antibacterial. Besides that, a lot of study also being carried out on modified starch coagulant from various starch that origin from corn, taro and cassava and also oil palm trunk. But basically, they specify in modifying monomer in terms of chemical monomer. Apart from that, alkaline steeping method had been adopted for this study for starch modification. The use of alkaline steeping method is to cleavage the glycosidic bonds between monosaccharide and in polysaccharide hydrolysis of glycosidic bonds with the water inside the granules. Apart from that also, this study focusing in removing the E. coli and the potentials of cassava starch as antimicrobial component. Before this, some of the coagulant also have the antimicrobial components such as moringa, chitosans and others coagulant. So these are the research background. In the beginning of the research, raw water sampling was collected from the outlet of the water sampling. For the second stage, in the lab, lemongrass was extracted from the raw lemongrass, and then further that, modified starch was prepared and characterized. Development of the modified starch by the initial work preparing the modified starch, and then after that extractions the cassava. Following that, we do the optimization study and finally the mechanism study. This is the picture of the outlet that we collected the raw water. Look at the picture. The raw water is so much green due to the algae that already coming into the raw water inlet. Water was tested based on standard method following AFA method. Some of the parameters that were tested are pH, conductivity, total dissolved solid, total suspended, DO, COD, turbidity, temperature, and ferrum, mangan, E. coli, and also total coliform. This is the method to achieve the objective one. Objective one is to characterize the chemical composition and antimicrobial properties of lemongrass extract. First, we start by knowing how lemongrass extract was prepared. Firstly, all the lemongrass was fragmented into pieces. Then the lemongrass was crushed dry. Then the lemongrass was extracted using the Socklet extraction. Then it was evaporated. Then lemongrass are ready for analysis to be analyzed in the GCMS. Following the lemongrass extract, antimicrobial study was performed. For doing antimicrobial study, lemongrass extract was diluted. Inoculum of E. coli was prepared, and this diffusion method was adapted to measure the inhibition zone. How much E. coli will be removed from the water sample. This is the method to conduct objective 2, that was to characterize the surface morphology and chemical compositions of alum, CPS and also CPS. From the raw cassava field, it will be scrapping. Then the scrap paradigm will be prepared into slurry filtrations. And then after that, the starch sediment was collected and the sediment was dried. After the sediment was dried, the sediment was further testing into few analytical machine for zeta potential analysis, HNMR analysis, XRD analysis, FTIR analysis, and as well as SEM, EDX analysis. So the table shows the optimization study condition for running the jar test. This is the picture showing that the treated water after coagulations and flocculations were performed, all the solid sample already settled downwards. Then the floc sample was further tested using SEM EDX analysis, FTIR, as well as particle size analyzer. The result was analyzed using ANOVA. Now we go for result and discussions. The first one, result on characterizations of the water. How does the water look like? So basically, once we get the value of the raw water, after few collections of the water, it will be analyzed, the minimum amount, maximum amount, and average value of each of the parameter. After we analyze, then we compare the standard with using Interim National Water Quality Standard of Malaysia 2005. Based on the standard, some of the parameter fall in class 1 and some of the parameter fall in class 2, class 2A, and also class 3. Okay, let us go on characterizations of lemongrass extract. What is the content of the lemongrass? So using the FTIR analysis, we can see that the lemongrass contain citral that was the antimicrobial component, and then comparable to pure glycinol compound, constituent of lemongrass have found to be exhibit a pattern of antibacterial that have potentials to treat the E. coli. Besides that, the GCMS also proven that the existing of the citral that was the active compound for microbial inhibition. In this case, the microbial that was inoculated is E. coli. So further to the experiment, using the petri dish, we can see that at certain percentage, 100% of E. coli was removed. Look at the figure. This shows the inhibition zone. Then we go to our result for objective 2, characterizations of coagulant. Characterizations of coagulant using coagulant like alum, cassava field starch, modified cassava field starch. Look at the first one. So for alum exhibit tetrahedral shape with average size of the agglomerous will measure around 40 to 60 micrometer. By using the FTIR spectrum, it shows that the presence of hydroxyl stretching in alum. These are the EDX spectrum, further confirm the presence of certain melter that we have in the process of coagulations and flocculations. This is the analysis of SRD of the alum. Crystal structure of alum is in tetrahedral shapes and surrounded by crystals formed by the orientations of sulfate tetrahedron. Then for SEM and EDX, then we go for the starch characterization, that was the CPS. For the SEM and EDX, the size of starch granule play an important role in modifying the structure. The FTIR shows that carboxyl and hydroxyl group were present in the cassava field. Following that, the XRD analysis proved that CPS exhibit typical type crystalline pattern with a strong reflection. SEM-EDX further confirm the presence of these are the presence of starch in the modified cassava field with lemongrass. You see that these are the granules. These granules are a very good component to settle down all the pollutant in the water. Okay, look at the SEM EDX for CPS for 20%, 40%, 60%, and finally 100%. EDX spectra modified of lemongrass shows that the presence of lemongrass had their own ability in removing the pollutant in the water. And further, the FTIR analysis further confirmed that certain compound that exist in the MCPS help in removing the pollutant, the compounds such as flavonoid, tetrapenoid, and polysaccharide. XRD also further confirm that significant amount of crystalline of starch exists in the compound. Using the SMR, it further confirmed the presence of aromatic compound in MCPS and also glucose CPS, but in the CPS only exists the glucose compound. Okay, now we go for objective 3, studies on the effect of pH, coagulant dosage, settling time, and coagulant performance. What are the effect of pH? By using LM, CPS, MCPS, LMCPS, and also LMMCPS. Look at the figure. LM reflect effective at pH around neutral in the range of 6 to 9. CPS and MCPS as a sole coagulant showed higher turbidity, and TSS removal was achieved at external pH range due to the action of cells aggregation. The E. coli removal demonstrating U-shaped pattern with the higher E. coli removal at acidic range. For LMCPS, both LMCPS and LMSCPS demonstrated similar coagulations and pattern against varying pH with highest turbidity of TSS, COD, and E. coli removal recorded at pH 7. How about the effect on coagulant dosage? Increasing LM dosage from 5 mg per liter to 15 mg seems to enhance turbidity, TSS, COD, and E. coli removal. Besides that, increase in CPS over MCPS dosage resulting in reductions of turbidity, TSS, COD removal due to difficult coulombic attraction. Increase the NCPS dosage, increase the infection effect where the E. coli removal up to 91%. How about the turbidity, TSS, COD removal and E. coli using LMMCPS and LMCPS? LMCPS and LMMCPS high treatment efficiency of coagulant despite large reductions in LM and CPS over MCPS doses when both coagulant were used in combination of dosage reduction of 50% of both coagulant. And what is the effect of settling time for LMCPS, MCPS, LMCPS, and also LMMCPS? For LM, increasing the settling period from 10 to 16 minutes has significantly enhanced the removal of turbidity, total suspended solid, COD, and also E. coli. For CPS and MCPS, almost complete sedimentation was achieved within 10 minutes of the settling time. For effect of the settling time for LMCPS and also LMMCPS, coagulation settling time using combinations of LMCPS and LMMCPS was 6 times much faster. This is about 6 minutes. Coagulation using dual coagulant of LM and CPS reflecting remarkable improvement in E. coli removal. Okay, look at this figure. This figure shows the first one is the raw water as the control. The second one is the raw water that been added by LM. The third one is the raw water that been added by cassava peel starch. The fourth one is the raw water that being added by modified cassava peel starch. The fifth one is the alum combined with the cassava peel starch. And finally, the last one is alum that combined together with modified. This one is so much clearer. For E and F, it is much clearer comparing to the control and other coagulant. Now, we go for the final objective. Then, because we want to know what happened on the mechanism and flow characterization and also electrokinetic study. So, mechanism based on the flow characterization and visible potential. SEM is in irregular morphology. Look at the morphology. On top of that, these are the irregular morphology. EDX that present, EDX indicate the presence of chlorine, mangan, ferrum, indicating that chemical precipitations. FTIR analysis, show the shiftings of the CH bond. This might be due to the ion exchange. For the flux size analysis, further additions up to 15 mg of alum increase the collisions between the particles. For electrokinetic analysis, maximum turbidity removal with the clear to zero zeta value at alum dosage of 15 mg per liter. So this is the result for CPS. For the CPS, it shows that the result of the CPH in the starch granule cluster, and in EDX it shows the presence of ferrum, mangan and also aluminium in the sample. For the FTIR analysis also show the shifting due to the interaction between suspended particle and coagulant material. For the flux size, higher dosage resulting reduction in the flux size due to electrostatic repulsions. For electrokinetic analysis, higher turbidity removal when zeta potential close to zero. This is the mechanism interpretations by using modified cassava peel. Look at the picture of SEM. It shows the involvement of bridging mechanism. For the EDX, it shows the complexations. A lot of metals will exist in the EDS. Besides that, for the FTIR analysis, it was observed that the presence of ion exchange. In terms of the flux size produced by MCPS is larger. This could be due to the electrostatic attractions. Finally, for the electrokinetic analysis, increasing the MCPS dosage with net charge at the optimal dosage or very close to zero, suggesting charge neutralizations. For alum and CPS, SEM shows the bridging mechanism, and for FTIR analysis also shows that the occurrence of shiftment of the functional group. For the flux size, extended and growing size of the flux compared to the treatment using alum alone. For electrokinetic analysis, change of neutralizations. Now we go for alum MCPS. SEM shows that the starch granule appeared to be encapsulated. For the EDX, it shows the ion exchange took place. And in terms of the flux size, microflux and rapidly produced during the rapid mixing stage due to the strong attraction between the hydrolyzed aluminium. And on electrokinetic analysis, it shows that the charge neutralizations predominant due to preliminary alum additions. Okay, now we go for the conclusions. For the objective one, as the conclusions, the ethanolic and methanolic lemongrass extract show the presence of monotriplanes, hydrocarbon and citral. Ethanolic extract recorded better antimicrobial potentials. The antimicrobial performance of ethanolic extract showed comparable result with the commercial antibiotic that was used in the study, that was ampicillin. For objective 2, LM showed tetrahedral morphology. CPS indicates spherical, fractured and bowl shape in the sheet with large granule size. The surface morphology and elemental distribution of MCPS are significant. For objective 3, pH, dosage and settling time are significantly affect the turbidity, TSS, COD and E. coli removal in the sample. The present study found the rankings of coagulant. For the first one, alum combined with modified cassava field, following by alum combined with cassava field, following by alum, MCPS and finally CPS alone. Integrated use of alum and starch also demonstrated to shorten the settling time 6 times faster. The result also indicated to the conclusion that CPS and CPS were not suitable to be used as a sole coagulant, but it could be possible to combine with other coagulants. For objective 4, alum coagulation mainly governed by charge neutralization as mechanism. CPS and MCPS as a sole coagulant exhibit similar mechanism behavior. For bridging chemical complexation, combination of use of alum with CPS and MCPS shows that the charge neutralization mechanism. So these are the main reference that being used in this study. This study also already published in high impact journal and many Scopus index journals. With that, I thank you.
Professor Norzilla couldn't be with us due to the time difference between North Cyprus and Malaysia, but I would like to send her our sincerest thanks for showing the courtesy of sharing her message with us via a pre-recorded presentation. Now I would like to invite Professor Dr. NURAY Atesh from Erciyes University to deliver her keynote presentation.
Hi everybody, I'm gonna show my presentation. Sorry. Okay, I think you can see my presentation.
Yes, Professor, we can.
Okay, thank you very much. Have a good day for everybody. First of all, I want to thank to Professor Dr. Hüseyin Gökçekuş and organizing committee to give me chance to talk in a such good conference and their efforts and interest. My presentation title is Pesticide Removal from Water and Wastewater by Absorption Process. My name is NURAY Ateş and I am from Erciyes University in Turkey. I will give some brief information about the definition and type of pesticide usage in the world, transport, fate, and occurrence of pesticide in environment, and related legislation and regulations. I will talk the treatment processes for pesticide removal, and I will show some examples pesticide removal by absorption processes. The pesticides are defined as a broad spectrum of chemical organic mixtures applied to prevent, destroy, and also control any unwanted species in the world. And the pesticides can be characterized based on its chemical structure, toxicity level, or target application. As you see, the spectrum of pesticide can be classified based on the target applications are insecticide, herbicides, fungicides, and rodenticides. On the other hand, the pesticides can be classified based on its chemical structure, organocolorants, organophosphates, carbamates, triazines, and others. Pesticide widely used for agricultural, industry, forestry, and household purposes. And when we look at the consumption of the pesticide in all over the world, annually 3.5 million tons of various pesticides are consumed. And the cost of these used pesticides approximately is $40 billion. The herbicides is the most used pesticide, most applied pesticide among the other pesticides, and it takes almost 50% of total consumption of pesticides. And the insecticides followed the herbicides. I want to show you a map. In this map, you can see the density of the pesticide consumption in the world. As you see, the most pesticide used in China, Japan, USA, Canada, and also Brazil. When we look at the Europe, the France, Italy are the most used countries, and Thailand follows them. In Turkey, the amount of pesticide used is in annually 1.66 kilogram per hectare. Pesticides can be applied to the for the agricultural purposes. It can be applied as spray, granulate, or seed treatment, and these applied pesticides can be distributed through different mechanisms to the air, soil, or water environment. When the pesticides distributed to the air, water, or soil, different mechanisms happen, and pesticide can be transformed or transported to the other media. The most possible transport mechanisms are the runoff and erosion, spray drift, seepage, drainage runoff, or atmospheric precipitation and volatilization. On the other hand, when the pesticide distributed to the environment, chemical or photochemical decompositions occur, or the microorganisms can decompose this pesticide. The most loss can be seen as the volatilization of the pesticides, and pesticides can be transported to the surface waters by runoff or seepage to the groundwater. Plant or other microorganisms or organisms can uptake some of pesticides and accumulate on their bodies. The pesticide can be also undergo the absorption processes by absorbed soil or organic matter in ground. The occurrence of pesticides in water and wastewaters depends on various factors. These factors, the most important factors, is related with the pesticide structure and also the type of and physicochemical properties of soil. Environmental conditions also affect the pesticide distribution or decomposition in the environment. The pesticides fate or pesticide transport are also related with the geographical distances between the application site and the aquatic reservoirs. The pesticides, some of pesticides can be lost or can be removed by just harvesting the growing crop during that time. and also the method applied of application of pesticide method also affect the occurrence and the concentration levels in water and wastewater. In this table, I want to show you some pesticides which were detected in the surface waters. These are herbicides and insecticides groups. As you see, the concentration level of these pesticides are in nanogram per liter levels. However, among them, alkyl, diuron, and terbinafines, the maximum concentration of these pesticides as much as in milligram per liter level. For example, especially the diuron concentrations is around 22 microgram per liter. So these concentrations, even in nanogram or microgram levels, it has severe and it has serious health effects on the living organisms. Occurrence because of the occurrence of the pesticides in water resources or wastewater systems cause serious health effects in both animals and human. When the fauna or flora are exposed to the pesticides, the chemical products are ingested or enter via the animal skin and accumulate in the traffic chain, in food chain. So eventually, these pesticides can reach to the people, human or animal bodies. The pesticide exposure has been proven in a result of the health effects, for example, immunosuppression, hormone disruption, reduced intelligence, reproductive distortion, and cancer. The impacts of pesticides also categorized into chronic and acute health effects. Because of the serious health effects of pesticides, the concentration and application amount of pesticide is restricted in many countries. The first legislation or the first regulation was published by USA in 1947, and then in recent time, in 2009, 43 pesticides were included into the contaminant candidate list 3. On the other hand, European Council also established a regulation which is called the Water Framework Policy in 2000. Then in 2008, 33 priority substances or groups are included to this directive, and also respective environmental quality standards were set. After that, 2013, the priority substances increased to the 45 number, and among them, 12 organic chlorine and 3 organophosphorus pesticides are including. In Turkey, we also adopted the Water Framework Directive, and in 2015, the regulation of the surface water quality management was published, and in this regulation, we accept the 45 priority substances or group substances, and also Turkey set the environmental quality standard for these pesticides to be met in inland and coastal waters. These pesticides are really serious and serious health problems, cause serious health problems, even in nanogram or microgram levels. So these pesticides should be removed from the water and wastewater systems. Conventional water treatment and wastewater treatment plants are not specifically designed to completely eliminate these pesticides. They cannot transform into less harmful compounds or even to mineralize them by conventional process. We need to apply other most advanced processes. To choose the suitable treatment technique is strongly based on the characteristic and aspects of the pesticide. The example of suitable treatment technique can be biodegradation, advanced oxidation, membrane separation, photodegradation, and adsorption. Compared to the other methods, chemical sorption was lower cost, more efficient, and faster than biological methods. It has some major advantages over the other treatment processes. For example, it is simplicity, flexibility of design, ease of operation, and insensitivity to the toxic contaminants removal. However, adsorption has also a major drawback, which is the requirement regeneration process. Many adsorbents can be used for the remove the contaminants, pesticides, or organic matters. So the adsorbents can be categorized in main three classes. Oxygen-containing compounds, for example, silica gel, zeolites, or bentonite. Carbon-based compounds include activated carbon, graphite, carbon nanotubes, and biochar. And the other group is the polymer-based compounds. Besides these adsorbents, nanoparticles and low-cost adsorbents, mostly derived from the organic waste, are used as adsorbent in absorption processes. Many factors affect the absorption processes. Absorption processes is a complex process, and each parameter sometimes depends. Each parameters depends on each other sometimes. For example, the pesticides characterization, such as molecular weight, polarity, hydrophobicity, or the functional group on it, and their water solubility is important, and also the absorbent characteristics are important. For example, structure, surface chemistry, and concentration of surface group on it. Besides them, the solution characteristics are also important, as temperature, pH, or presence of the other background organics or inorganics material. Absorption efficiency is defined mostly the absorption capacity. Absorption capacity can be determined by the taking difference between the initial concentration and the equilibrium concentration of the contaminants or pesticides per each gram of adsorbent. The equilibrium is used to compare the different contaminants absorption. Up to date, 15 different isotherm models have been developed. The definition of the isotherm model is the equilibrium behavior is characterized by expressing the amount of contaminant adsorbed as a function of concentration at a constant temperature. Among all isotherm models, Langmuir and Frontley are the most used, most applied isotherms to the adsorption processes. I want to conclude all results reported in the literature. The efficiency increased with the increasing adsorbent dose because the more surface area was available for the adsorption, and also the rate and extent of pesticide adsorption by adsorbent decreased by the increasing particle size, because it is related with the surface area. When the particle size is getting bigger, the surface area is smaller. Available surface areas are smaller. On the other hand, the temperature effect is temperature also affects the adsorption capacity and adsorption efficiency. Mostly the adsorption is applied in temperature between the 20 to 50 Celsius degrees, and in this temperature rate, when the temperature is increasing, the efficiency of adsorption is getting decreases, because the most of the pesticide adsorption process is exothermic. So the adsorption efficiency is much more at the lower temperature. However, in the high temperatures, because of the viscosity of the solution decreases, the rate of diffusion of adsorbent molecules across the external boundary layer in the internal pores of adsorbent particle is increased. The pH effect of pH on adsorption is complicated, because it depends on the solution pH, and also depends on the pesticide pH PZC values. If the pH PZC values higher than the solution pH, at that time all pesticides are protonated, and the interaction, the electrostatic attraction is the electrostatic attraction between the adsorbent and pesticides is getting higher. So in acidic medium, that is why in acidic medium the pesticides get protonated and become positively charged, and because of the higher electrostatic attraction, the adsorption capacity and adsorption efficiency is getting higher. The reverse also true. If the pH PZC value of the pesticides is lower than the solution pH, at that time the pesticides charged negatively, and the negative attraction occurs, and the adsorption capacity and adsorption efficiency decreases. Pesticide solution with low concentration attained equilibrium faster than the higher concentration. When we look at the kinetic models, most of the pesticide adsorption process obey the pseudo second order kinetic model. If we apply the mixing or agitating in the system, the rate of adsorption also increases. The presence of other organic matters or natural organic matters reversely affect the pesticide adsorption, and the capacity and adsorption efficiency decrease because of the competitive reaction between organic matter and pesticides towards the adsorbent. And when we look at all studies in the literature, we can just say, in general, we can say the adsorption performances varying between the 60 to 99%. This study is a part of our project, which is supported by the financially by the Scientific and Technological Research Council of Turkey. So we want to thanks to TBTAC for their support. And I want to thank for all participants and audience for listening me. Thank you very much.
Thank you, Professor Atesh, for the valuable presentation. Our next guest is Professor Madhavi from India. The stage is yours, Professor.
Good evening to one and all present here. So let me introduce myself. I am Dr. T.PHANI from Bapatla Engineering College. So I have been connected with the Department of Civil Engineering at Bapatla Engineering College, which was located at Bapatla, Andhra Pradesh, India. So first of all, I thank the organizers for giving me the opportunity to share my views about the topic that is SWACHH Bharat Mission, which is an transformational behavioral change program towards waste management for achieving the sustainable rural clean India. So this is the topic I am going to share today to create awareness about SWACHH Bharat Mission, which is an active mission in India. So this is the topic I am going to talk about SWACHH Bharat Mission, a transformational behavioral change program towards waste management for sustainable clean rural India. So if we want to achieve 100% sustainability to lead a quality life, there are several societal issues are there. Among them, waste management is one of the important issue to focus more on this to achieve the sustainability and to transform the nation into the clean nation. So these are the contents I am going to speak. Introduction about the SWACHH Bharat Mission and its importance of SWACHH Bharat Mission in India. So before going to talk about, we should know about what is the need of waste management. If the waste is not managed effectively, how it will impact our lives. It is not only the matter of an individual nation, it is the important issue which everyone has to focus more on waste management. And transformational behavioral change, how to bring this change and how to bring the change in the attitudes of the people to know the importance of waste management and how to achieve the cleanliness for sustainable clean rural areas. As we know, the rural areas needs to develop a lot towards cleanliness and lot of measures are required to achieve the cleanliness and neatness. Then only we can achieve the sustainable nation. And what are the best practices in India for sustainable clean rural India? What are the best practices we are following in our country? So these are the topics I'm going to speak. So let us talk about the cleaning. So what is its importance? Cleaning and neatness. These two are important things which we have to play a vital role in our life to lead quality and hygienic life. Suppose if there is no hygienic life, what will happen? We cannot live healthy life. So we may be affected to several vector-borne diseases, or we may be affected with several water-borne diseases due to lagging of cleaning and neatness. So cleaning should be the main need and significant for each resident of the nation. So that's why it is the best start of the disposal of social issue from the general public, just to raise the advancement of nation and development of the nation. So it is exceptionally useful for our survival on the planet Earth. So that is the importance of hygienic life and to lead a quality life. So cleanliness is godliness. So we have to keep cleanliness which is equal to the, because as we know, we all will pray the God every day, and we will ask so many of our desires in front of the God. So we have to, that's why this cleanliness also is one of the important tasks we have to consider equal to the God. And if we are clean, then automatically our life also will become so clean. So that is the importance of cleanliness is godliness. So cleanness and neatness is very imperative to all of us to keep ourselves physically, rationally clean with a decent character and in connection with the general public. So it is the mantra of Mahatma Gandhi, who is illustrated, and he is the person demanded for individual and network neatness for an amazing duration. So this is the mantra of cleanliness is godliness is the mantra of Mahatma Gandhi. So cleanness and neatness imparts perfect character in the general public, and the practical implementation of neatness drive. So in India, the neatness drive was remarkably taken by the government of India. So in this neatness drive, 30 lakhs government workers are actively involved in India to reach the goal of cleanliness. So the idea of Swachh Bharat, it is coordinated with the Swachh Bharat mission is coordinated with the Swachh Bharat Abhiyan towards understanding the excellent vision of this. So in order to satisfy the dream of Gandhi, a spotless and sterile India, the Prime Minister himself initiated the neatness drive by getting the floor brush to clean the earth, making Swachh Bharat Abhiyan, which is a mass development the country over. The PM said that individuals should neither litter nor let to others litter. So that is the idea of Swachh Bharat mission, and it is coordinated with Swachh Bharat Abhiyan towards understanding the excellent vision of this. Here, this Swachh Bharat Abhiyan, and one more important task was the Swachh Bharat Abhiyan Gramin works under Department of Drinking Water and Sanitation, and Swachh Bharat Abhiyan Urban, it works under the Ministry of Housing and Urban Affairs. So this is the variation between Swachh Bharat Gramin and Swachh Bharat Abhiyan Gramin and Swachh Bharat Abhiyan Urban. What is the importance of this mission in India? As we know very well, sanitation is the basic need of human beings. So without proper sanitation, we cannot lead the dignified life in the society. So the rural sanitation program, it was introduced in the year 1954 in India as a part of a first 5-year plan launched by the government of India. So for last many decades, India took steps to improve the access to safe sanitation and cleanliness. But still, after getting independence, after 32 years, the sanitation coverage was only 2% in the year 1982. It was noted, it is only 2%. So in the year 1982. So that's why Central Rural Sanitation Program, CRSP, was started in the year 1986 for rural sanitation by Government of India with the prime objective of improving the quality of life who are residing in the rural areas and to protect their privacy, particularly to maintain the dignity of women. But the focus mainly on toilet construction and related funds allocation. So in this Central Rural Sanitation Program, it was the objective is very clear, but there is no strong focus on the behavioral change of the people. So due to that reasons, the desired results were not achieved by this program. So here the sanitation coverage was slightly increased to 9% due to the impact of this CRSP. Even though it was not majorly focused on behavioral change, but due to the objective of this implementation of this Central Rural Sanitation Program to improve the quality of life in the rural people, after the implementation of this program, there is some increase of sanitation coverage due to this program. So this total sanitation program, TSC, it was started in 1999, and after that the Nirmal Bharat Abhiyan in 2012 were launched. From 1999, a demand-driven approach under the total sanitation campaign, which was emphasized the awareness among the rural people and generation of demand for sanitary facilities. So here the main objective of this total sanitation campaign was to provide the quality life, to maintain the sanitary facilities in association with the government agencies. So that's why this from 1999, the demand-driven approach under this total sanitation campaign creates awareness among the rural people, and to make them to create awareness about this, about the importance of cleanliness and neatness. Till 2014, in India, the sanitation coverage was below 39% only. So, particularly in rural areas, around 55 crore people, they does not have sufficient toilet facility. So, these kind of situations have severe impact on health and hygiene of the people, particularly in rural areas. So, due to this less sanitation coverage, lot of waterborne diseases and vector-borne diseases are greatly creates a problem on the health of the public. So what is the need of waste management? So in India, especially in rural areas, so the waste is it will be a severe threat for the survival of the public, and also it will impact on their health and cleanliness. Here, there is a genuine initiative of waste management in rural areas has been strongly raised in India due to large quantity of waste generated in the form of solid and liquid waste. So the task of waste management has becomes one of the key focus of sustainable development principles. So solid and liquid waste management is one of the key components for any sanitation initiatives, which is highlighted by Government of India under the flagship program of total sanitation campaign. If you are not properly managing the waste, it will completely spoil the healthy life of people, which will adversely impact on the survival of human beings on the planet Earth. So that's why there is a need to properly manage the waste by implementing proper waste management methods. So rural people in India are producing waste, liquid waste of 15,000 to 18,000 million liters, and solid waste of 0.3 to 0.4 million tons per day, respectively. So as a result of this, due to improper disposal of solid and liquid waste, several diseases such as diarrhea, polio, cholera, typhoid, malaria, dengue was drastically increased due to the improper disposal of solid and liquid waste. So 88% of the total diseases are due to lack of clean water and sanitation and improper disposal of solid and liquid waste management. The main objectives of waste management methods, particularly in rural areas, are to protect human health and to improve the quality of life, and to reduce environmental pollution, to promote recycling and reuse of both solid and liquid waste, and to create employment for rural people by providing new opportunities, by training them in waste management, and to convert bio-waste into energy at villages, particularly in rural areas. These are the main objective of waste management methods. So we are having several waste management measures, but the main objective is to achieve all these goals in order to provide the quality life to the people. So that's why there is a need of waste management. So transformational behavior change. How to bring a transformational change through the attitudes of the by improving the attitudes of the people. So Swachh Bharat mission was aimed majorly to focus on transformational behavioral change to enhance the quality of life of people, particularly in rural areas. So that's why it is a nationwide campaign which is launched by Government of India with a major focus on construction of household and community owned toilets and how to use those toilets, and solid and liquid waste management by establishing the stable mechanism in order to achieve the open defecation free India. So first, the main important objective in the Swachh Bharat mission is to completely abolish open defecation. All villages, states and union territories, villages in India declared themselves as open defecation free by 2nd October 2019 on the eve of 150th birth anniversary of Mahatma Gandhi by constructing over 10 crore toilets in rural India at a projected cost of over 1.3 lakh crores under phase 1 of Swachh Bharat mission. So in phase 1 of this mission, all villages, states and union territories declared as open defecation free by October 2nd, 2019. So the Prime Minister, the Noble Narendra Modi is the first Prime Minister. He was dedicated himself to raise this often ignored subject into a public discussion, and he diverted the people's attention towards cleanliness. So by protecting the dignity of women has been his first priority, and accordingly he has taken up this task of providing toilets to all households in the country in a time period of 5 years. So he has fixed the time bound goal for a duration of 5 years. So he started himself involving in the construction of toilets in rural areas, and he is the person initiated this Swachh Bharat mission to completely achieve the cleanliness and to make the India as a clean India. Achieving cleanliness for sustainable clean areas. How to achieve cleanliness for sustainable clean rural areas? To achieve cleanliness in the rural areas, the Prime Minister of India was fixed the time-bound goal for duration of 5 years and a fixed vision. So the time-bound goals was not only set in an energetic and dedicated manner, but all the goals were achieved within the set time duration also. So the Prime Minister of India has been prioritized the behavioral change initiatives for safe and effective sanitation by participating in the toilet construction, and he personally leading the massive people's movement and Jana Andolan campaigns for achieving Swachhata in the nation. So he has been the communicator in chief of the mission by inspiring the country to make the shift from open defecation to open defecation free India. The Prime Minister's persistent communications have been the most strategic and predominant asset of this mission. So he personally wrote to all 250,000 Gram Pradhans by motivating and encouraging them to take benefit and advantages of Swachh Bharat Mission Gramin provisions and help people in their villages to achieve the sanitation services. So this was mobilized the Gram Pradhans across the country, and village after village started achieving universal sanitation and made the villages open defecation free. So he is the man actively involved to transform the nation into the sustainable clean rural India. So there are several best practices are ongoing in India for a sustainable clean rural India. The first one is Swachhagrahis. So Swachhagrahis means these are the volunteer people who will actively involve in the cleanliness program by forming the Swachhagraha campaign. So twin pit toilet technology for rural areas. This is one of the best practice. So for rural areas, the twin pit toilet, it is an easy available and economic toilet option. So in this technology, 2 pits will be dug closest to the toilet. So these pits are used alternatively. Both pits are connected with a junction chamber at one end, and the pit walls have a honeycomb structure, and the bottom of the pit was earthen. So depending on the number of users of the toilet and the size of the pit, it will vary. So the capacity of each pit is kept for a duration of 3 years. So first pit, after it gets filled in about 3 years, it will be blocked at the junction chamber, and the second pit will start to operate. So the watery part of the excreta percolates in the soil through the honeycomb structure. So after 2 years, the blockage of first pit, its contents degrade completely and turns to solid, odorless, and pathogen-free manure. So it is dug out the beneficiaries and used for other purposes such as agriculture and horticulture activities. So after the second pit is filled, it is similarly blocked just like first pit, and it will be used again. So this is the twin pit toilet technology for rural areas. And another best practice is annual surveys will be conducted by independent agencies and IEC division. So this is the division that is information, education, and communication division also will be connected to the this as a best practice, which will create a lot of awareness about this program. The iconic campaigns like Darwaja Band, Saaf Nahi to Maaf Nahi mobilized and connected citizens across rural India. And social media such as Facebook, Twitter also plays an active role about this Swachh Bharat mission, to create awareness about this mission in the public. Extensive field visits and monitoring also will be conducted throughout the nation. Active involvement of ministries and departments of government. Women participation and leadership are also there in rural areas to create awareness about several sanitation issues and cleanliness issues. And the role of children. So more than 5 crore school children made essays and paintings about Swachhata in the country, and over 1.3 lakh children of around 1700 schools from district of Kabirdham of Chhattisgarh state. So they wrote letters to their parents for construction of toilets at their homes. So the entire district was motivated by this initiative of children, and it has a remarkable impact to transform into the open defecation free district in a very short span. So these are all the wonderful best practices in India to achieve the cleanliness through Swachh Bharat mission. Apart from these various initiatives like Swachhata Pakwada, Swachhata Action Plan, Swachh iconic places was jointly implemented by all the ministries and departments of the government, state and central governments. Under Swachhata Action Plan, around 72 ministries and departments have contributed over 80,000 crores towards Swachhata activities. So, and the railway ministry installed bio toilets by replacing open toilets in train coaches. Separate toilets for boys and girls were constructed in all schools. More than 80,000 community toilets have constructed in public places across the nation. So these are all the several initiatives and practices which was taken up by the government of India and also by the people of India. So under Swachh Sundar Sauchalaya campaign, over 1.3 crore toilets were decorated with beautiful paintings and messages in a duration of only 1 month. So many companies came forward to work in the area of solid and liquid waste management and toilets construction. So Tata Trust contributed by providing around 515 talented young professionals for a duration of 2 years. This is a very good contribution by the Tata Trust to achieve this mission. India played a crucial role in generating mass awareness with sanitation messages. Media also widely covered and disseminated sanitation issues, government schemes, events, and goals, which contributed to transform Swachh Bharat mission in a Jana Andolan. So these are all the several initiatives where the companies play an active role, by the government, state governments, central governments, panchayat raj, all these ministries, everyone's involvement is actively contributed for this Swachh Bharat mission campaigning programs in many forms, such as Swachhagraha campaigns, by implementing a twin pit toilet technology, by conducting annual surveys, and IEC division also plays an active role for effective implementation of this campaign, of this mission. Social media also, such as Facebook, Twitter, Instagram, all these also actively involved in this mission to create awareness among the nation about the importance of cleanliness and sanitation. Role of children also actively involved in this. Women participation and leadership. So thank you very much for the opportunity given to me.
Okay, thank you very much for your speech, Professor. And thank you very much to all professors who have joined and honored us in this session. Professors, anything you would like to add? Okay, if not, then I would like to announce that this is the end of the second session, and the next session will begin at 2 o'clock in the afternoon.